Hello, everybody. Once again, I am here with you for the next session related with the solid state physics paper number 13A. Myself again, Dr. S.D. Chavan, Department of Physics, Adarsh College, Hingoli. In the previous session, we have seen what is exactly meaning to be the types of the lattices are to be there, in which important factor in the two-dimensional and three-dimensional Bravais lattices are to be there, and we have seen exactly what is mean by the Bravais lattices and the two-dimensional Bravais lattices in detail. Basically, the thing starts with the point groups, and point group is nothing but to be what exactly as far as two-dimensional things or three-dimensional things are going to be concerned, that the whatever be the symmetry is going to be operating surrounding one point, that includes the particular points or the atoms, that is nothing but to be your point groups are to be there. And basically in the two-dimensional thing, the point groups possible are 10. The space group, which contains not only the symmetry points, but it also contains the whole element crystal structures, whole elements of that crystal structures are to be there, and that is nothing but to be 17 space groups are possible in two-dimensional things are to be there. When any lattice which is going to be following or consistent with the point groups, that is nothing but to be called your basically Bravais lattices. And in three-dimensional case, there are five Bravais lattices we have seen in detail, and the possible crystal systems are four. As far as the three-dimensional case is to be there, there are 32 point groups, and 230 space groups are there, and 14 Bravais lattices are going to be formed, and with that the seven crystal systems are going to be formed. Now today we will see about the three-dimensional case, or the what exactly the three-dimensional Bravais lattices are to be there. And to understand this case, what exactly it contains, that is very important factor. As there are three-dimensional case, the three vectors are going to be there, that is A, B, and the C is to be there. This is supposed to be as a 3. These are the three vectors suppose, and A, B, C is going to be there. Now in this case, O is nothing but to be origin point at this stage. This is what the O point is to be at this stage. This is what O point, and these are the A, B, C vectors are going to be there. Now what exactly important factor as far as three-dimensional case is to be there, these two vectors are there, always there is an angle in between them. That angle is very much important. As far as alpha angle is to be there, it is the angle between the vector B and C. As far as the beta is to be there, it is nothing but to be the angle, as here it is shown that part. The alpha is nothing but to be the angle in between the vectors B and C. As far as beta is going to be the angle in between the C and the A vector, and the gamma is nothing but to be the angle in between A and B vectors are to be there. Now this is what the case where it is to be very much important factor, that what exactly to be your case where it is to be as an related with the part, that is what is to be as an crystal systems are three-dimensional Bravais lattices are to be there, in which these three vectors are playing very important role, and these angles or distances as far as or the lengths of these vectors are going to be defining what exactly how the lattice is going to be there. And as far as the three-dimensional case is to be there, it is the three vectors that forms your unit cell, and that unit is going to be continuous in that lattice. Now whatever be this alpha, beta, gamma angles in between the vector B and C, angle between the vector C and A, and the angle between the vector A and B, all these parameters, that is alpha, beta, gamma, and A, B, C, are the your vectors are to be as an unit cells. All these are called to be as in your lattice parameters, or the lattice constants are to be there. Not only this part, but also with this case there are additional things which are notifications are going to be used in this your three-dimensional Bravais lattices are to be there. Now what exactly the symbols are going to be used, and what exactly the meaning for that symbols are to be there. As far as P symbol is to be given for any crystal lattice or the unit cell, that's simply showing you it is nothing but to be a simple or the primitive type of the case, or the primitive unit cells are to be. As far as the F is going to be there, it means to be as an face center. As far as I is going to be there, I symbol is representation for the body center, and A, B, C are the three another uh, alphabets or the symbols which are going to be used for the base or the centered lattices at the corners, that is to be there, and at one end of the pair, means either at the corners or at the two ends, either top bottom or the front back or the left rights are to be two at the one end of pair of the are to be there, opposite one at the one of the pairs of the opposite faces are to be there, that is either top bottom, left right, front back, likewise this is to be there. And R symbol is going to be used for the your rhombohedral lattices are to be there. This is what the symbolic representation as far as the three-dimensional lattices are to be there. Now let's see what the 14 Bravais lattices are to be there, and in detail what exactly it gives us the information. So as far as the 14 Bravais lattices are to be there, we will already aware about that in the three-dimensional case. The Bravais lattice is nothing but to be that lattice or which contains or which follows the point groups, and in three-dimensional cases there are 32 point groups are possible, and those lattices created or consistent with this particular your point groups, that is 32 point groups in the three-dimensional, these lattices formed with this case are nothing but to be your called to be as an Bravais lattices, and 14 type of the Bravais lattices are possible in the three-dimensional lattice. Now here is the first case where it is called to be as an simply your first Bravais lattice 14 we will see, and it is having the seven crystal system. This is the first crystal system, and each crystal system having either two or three, whatever be the according to the possible uh, directions, or possible unit cells, these Bravais lattices are to be made. Now here are the first one Bravais lattice, which comes under the first crystal system, and it is called to be as an cubic. Now in this case, if you look at here, it is to be nothing but to be as far as alpha, beta and gamma three angles are, if you looked at this alpha, beta, gamma. Before that, a, b, c are the vector, as alpha and the your angle is in between b and c part is to be there. Now here it is to be as an given, likewise to be as an beta is the angle between c and a, and the gamma is the angle between the your a and the b is to be there. Now if you look at here, it is nothing but to be your vector here. If you look at here, everywhere written to be as an a, but it is why it is to be written as a, because a, b, c, all these three vectors, that is to be, this one is to be a, this one is to be b, and this one is to be the c. All these three vectors are of same length, and that's why the same word to be written, that is AAA, that is it is having equal lengths. Three vectors A, B, C are having equal lengths, and that's why written word here it is to be A is equal to B is equal to, if you look at this case, A is equal to B is equal to C is to be written. Now in this case again, the very important factor is to be as we are already aware again that alpha is the angle between vector b and c. So definitely it is supposed to be this a vector, this is your b vector, and this is your c vector is to be, and beta is the angle between the c and the a. That's why this beta is to be the angle where it is, if you see, it is angle between the c and the a vector, this is a vector. And lastly the gamma is the angle between the a and the b vector is to be there, so that's why it is to be the b. This vector is called to be as a your c vector. So here are the a b c three vectors, but here the same as a word is to be written because all the vectors are having the same length, and that's why this a is to be written to understand that all the vectors are of a equal length. Now as far as the angles in between these vectors, that is alpha, beta and gamma, all these are having the exactly equal angle, and that is nothing but to be 90 degree. So this is what the cube is going to be formed with these vectors, or the unit cell is going to be formed with these conditions, that is a is equal to b is equal to c, and alpha, beta, gamma is equal to 90 degree. So such type of the cube where it is to be formed, it is called primitive simple cubic, or it is comes under the notification that is to be primitive, or the p word is going to be used or simple word p is used for the simple or your primitive case is to be there. And the examples for such type of the crystals are nothing but to be cu, ag and fe, that is the copper, silver and iron is nothing but to be the three cases are examples for this type of the crystal system, or the Bravais lattice is going to be there. So this is how the simple cubic structure is going to be there, or the first Bravais lattice, three-dimensional Bravais lattice is going to be formed. So again here if you look at the next part, that is to be the second Bravais lattice, if you study, it is nothing but to be likewise this. Again here as you can see, the three parts a b c vectors are of equal length, that's why here to be as and written as a in the same way. But if you look at here in this particular cube, the important factor is to be that points or the atoms are not exactly on the corners, but there is one another point which is exactly at this stage. Here if you look at this stage, here is the one another point which is, or the atom is to be there, and basically which gives you the relationship for the basically showing you the difference in between them. Otherwise all these cases are to be as in similar, as we are looking for the cubic structure. This is the second Bravais lattice, and the same crystal system we are learning. That's why the whatever be the, when the crystal system is going to be same, similar pattern it will show, that is a is equal to b is equal to c, it is already there because it is related with the same crystal system is to be there. And as far as alpha, beta and gamma is going to be concerned, it is having the angle 90 degree. And all the things are similar to the whatever the primitive simple cubic is to be there, but only one thing is going to be added, that is this one atom is exactly at the center of the body. And that's why such type of the your Bravais lattice or the unit cell is nothing but to be called as a body centered, because at the center of the body there is one atom is to be there, and that's why it is called body centered cubic is to be there, and it is to be notified with the I symbol is to be there. Examples are Na and NaCl, that is sodium and sodium chlorides are the two examples. Now this is what the another part where it is to be the second Bravais lattice is to be there. The third Bravais lattice, or the three-dimensional third Bravais lattice, is also with the same crystal system, and that's why I have written, if you look at carefully, if the crystal system is to be same, I have taken it as to be as an what type of the crystal system we are learning, and this is what the number, that is 14 Bravais lattices we will learn. This one is the third one. Now here if you look at this case, as far as this three-dimensional Bravais lattice, that is to be as an concerned with the your first crystal system, again it is cubic, and that's why a is equal to b is equal to c, that's why it is forming a cube. And alpha, beta, gamma are similarly having the 90-degree angle in between them. As far as the AAA is written, that shows likewise this. But if you look at carefully, the every surface, now cube is having the 6 surfaces, and in every surface there is a one point which is exactly at the center of that surface. Here it is to be for this, here it is for the left one, here it is for the back side, here it is for the front side, here it is for the bottom side. That means if you look at, there are 6 points which are located at the center of each face, and that's why the such type of the lattice or the unit cell is nothing but to be called your face centered cubic, and it is denoted with the F is to be there. Now here in this case the example is to be CSCl, that is cesium chloride is the one of the example for this crystal system or the Bravais lattice is to be there. The whatever be the points or the atoms are not exactly on the corners, but the atoms are also on the center of the surfaces, and that's why this such type of the units lattice unit cell or the lattice is called to be as an face center cubic is to be there. So this one is the your third one, Bravais lattice. Now moving forward for the fourth one, Bravais lattice. Here it is to be as an your fourth Bravais lattice. Now in this case the crystal system is going to be changed. That means in the first crystal system we have seen three Bravais lattices, that is simple cubic, another one is body centered cubic, and the third one is to be face centered cubic. The differences in between them was exactly simple cubic was the all the points are exactly on the corners. In the body centered cubic, not only on the corners of the your cube, but also inside the center of the body there is one atom, and that's why it was to be called to be as an your body centered cubic. And the third one is to be the atoms are not exactly on the corners but also on the each surface, and at the center of each surface is to be there, means the additional atoms are exactly on the each surface or center of the each surface is to be there, and that's why it is called to be as an face center cubic structure is to be, or lattice is to be there. And all these comes with the part A is equal to B is equal to C, and alpha beta gamma is equal to 90 degree, and that is all these your Bravais lattices, three Bravais lattices come under the first crystal system. That name is that is called to be as an cubic is to be there, that is simple cubic or the primitive cubic, or it is to be another one is to be body center cubic, and the third one is to be your face center cubic. Now this is another crystal system, and the fourth Bravais lattice is number is 4. And here it is, if you look at the difference, like this one is the fourth Bravais lattice, and this one is to be as in your second crystal system we are learning. Now again alpha beta gamma and the a b c three vectors are to be there. Now here if you look at carefully, a is equal to b, but b is not equal to c, here it is the case. That means the two vectors a and b are equal, a and b are equal, but the c is not equal, it is of different length, and that's why a is equal to b but not equal to c is to be there. But again all the alpha beta gamma are having the angle 90 degree. That means as far as previously also we discussed, the alpha is nothing but to be representing the this angle between the vectors, as far as your b and c is to be there. As far as beta is nothing but to be the angle between the vectors a and c, and whatever be the angle gamma, it is nothing but to be in between the vectors, that is a and b are to be there. And these angles are similar, only the difference in the previous crystal system and this one is that a is equal to b but b is not equal to c. This is a simple one difference, but it one difference create a different crystal structure, or the different crystal lattices are going to be formed. So this is what the comes under the tetragonal system, and this one is the another example for the your Bravais lattice. And the such type of the your case where the all the points are exactly on the corners, there are the points are exactly on the corners, not anywhere inside that surface or the inside the body, and that's why it is called to be as in your simple tetragonal lattice is to be there. And tin is the example, that is Sn is nothing but to be as an example for the such type of the Bravais lattice is to be there. So it is again denoted with the p, that is simple is to be there, or the primitive you can call. Now the next Bravais lattice, that is the fifth Bravais lattice. in which this is also the part of your second crystal systems is to be there. There are 14 Bravais lattices and the 7 crystal systems are to be there. This one is the fifth Bravais lattice and the second crystal system is to be there. Again it is related with the same part, that is nothing but to be your part of the tetragonal. That's why here A is equal to B but not equal to C is to be there. And alpha beta gamma are having the 90-degree angle is to be there. And if you look at here the case A is equal to B, that's why A here this one is the A vector and B vector is also shown here with the A factor, because A and B are having the same length and that's why A is equal to B, but it is not equal to C, and that's why here if you look at this one is the C vector, this C vector is of different length. And as good as alpha, this is what the alpha, this is what the beta angle, and this is what the beta angle, and here it is to be as in gamma angle is to be there in between A and B is to be there. So all these are having the 90-degree and such type. And another, if you look at this case where instead of this there is a, the atoms are the points are not only on the corners but there is a one point inside the center of the body, and that's why such type of the example is nothing but to be body centered tetragonal, and it is denoted with the I. And the example for the such type of the Bravais lattices is nothing but to be TiO2, that is titanium dioxide is to be there. So this is one of the another fifth Bravais lattice, three-dimensional Bravais lattice is to be there. Now the sixth Bravais lattice, which comes under the third crystal systems, third crystal system is to be there. That means there are two points or the two Bravais lattices in the previous tetragonal system, crystal system we have seen, and this one is the third crystal system, that is orthorhombic is to be there. Now in this case what exactly the case, that three vectors if you look at A B C, all these three vectors are not equal to each other. That means A is not equal to B is not equal to C. That's why here it is to be written A, B and C, different vectors are of the lengths are to be there. Again the main factor it is not going to be changed, that is alpha beta gamma, the angle in between them is again 90 degrees to be there. And such type of the case, if again the important factor all the points are exactly on the corners of the your orthorhombic case, or the cube is to be there, and in that case the whenever the points are exactly on the corners which not in another place, then in such a case it is called to be simple orthorhombic, and so it is denoted by the P. And the example for the such type of the crystal lattice is nothing but to be galenium. And this is what the another crystal another Bravais lattice is to be there, which comes under the third crystal system. Now moving forward, the another seventh Bravais lattice, which is also to be related with the same crystal system, that is the third crystal system, that is orthorhombic. And in this again the similar parts we will see, that is A is not equal to B is not equal to C. That means A B C all three vectors are of different length. And again if you look at the alpha beta gamma are having the 90-degree, that is the case for the orthorhombic. And but all the points are not only on the corners but there is one point exactly at the center of the body, and that's why it is called to be as in body center orthorhombic, and it is denoted by the I is to be there. And example for the such type of the Bravais lattice is Fe3C is to be there. So this is what the seventh Bravais lattice, or which is to be related with the your third crystal systems system is to be there. The another one is to be the next crystal lattice or the Bravais lattice, eighth Bravais lattice is to be there, which is also the part of the your third crystal system is to be there. That means again if you look at A B C are not equal to each other, that means are all three vectors are of different lengths are to be there. Alpha beta gamma is equal to 90-degree, that means the alpha beta gamma are having the 90-degree angle in between them. And if you look at this case carefully, the whatever be the points or the atoms are on the corners, as well as there is two another points or the atoms which are at the one is to be at the center of the top end, and another point is to be at the bottom surface, at the center of the bottom surface is to be there. And here in this case it is called to be as an end center orthorhombic. The orthorhomb is to be there, but the two additional points are at the center of opposite to each other. This such type of the pair is to be there, and that's why it is denoted with the C. As already at the beginning stage we discussed, A, B, C are the three symbols which are going to be used for the end centered, that is at the end, that is top or bottom, left or right, front or back. Such type of the pair is going to be there. Here the pair is at the top surface, at the center of the top surface, and at the bottom of the center is to be there. Points are to be there, and that's why this is called to be as an your end center orthorhombic. And it is having the example as cementite is the another example for the such type of the Bravais lattices are to be there. Now the next ninth Bravais lattice is to be the again the part of your third crystal system, that is your orthorhombic is to be there. And if you look at again, A is not equal to B is not equal to C, that means all three vectors are different, of a different length. Alpha, beta, gamma is equal to 90 degree. And if you look at this carefully, all the points are not only on the corners, but there are the points on the surface and at the center of each side. That means there are six surfaces as far as the cubes type of the structure orthorhombic is to be there, and each point is to be at the center of the face, and that's why it is called to be as an face centered orthorhombic. And it is denoted with the F is going to be there. So this is one another third crystal systems part. That means we have seen nearly four type of the Bravais lattice comes under this orthorhombic. And that is if you look at carefully, this one is to be face centered, another we have seen that is end centered, and the body centered, and you have seen the simple orthorhombic. These four Bravais lattices comes under this third crystal system is to be there. Now these are the four, that means it becomes 5 plus 4 9 Bravais lattices we have seen. Now let's move towards the 10th Bravais lattice. What exactly the difference for this one case is to be there, and which is the 10th Bravais lattice which comes under the your fourth crystal system. And in this fourth crystal system, if you look at again the three important vectors, that is A is equal to B is equal to C. That means the A, B, C three vectors are same. That's why it is noted with the common to be word used as a AAA is to be there. As previously discussed, alpha, beta, gamma all are having 90-degree angle in between them. That means to be in between the C and A, the angle is alpha, that is 90 degree. That is the again the angle between the sorry, B and the C, that is the angle is 90 degree, that is alpha. In between the C and the A, that is the angle beta, that is also 90. And the angle in between the A and the B, that is also called to be as an gamma, it is also important factor. Gamma is not going to be 90 in that case. So the third one, that is the angle in between the A and your C, sorry, A and the B vector is not going to be 90 degree. Only alpha and beta are to be 90 degree. That means the angle in between the vector A and the B is not equal to 90. This is what the difference for the your 10th Bravais lattice. And the such type of the your crystal lattice is nothing, or Bravais lattice is called to be as an simple rhombohedral case is to be there. And wherever the rhombohedral case is to be there, we always noted with the capital R. And as far as the examples are AS, SB and BI, that is arsenide, bismuth are the examples for the such type of the Bravais three-dimensional Bravais lattice is to be there. The another one case where here again important factor in this case is that all the points are exactly on the corners of the whatever be the rhombohedral structure is to be there. And that's why whatever be the example comes under the simple or the primitive, but it is rhombohedral, that's why the notation is R is going to be used. Now 11th Bravais lattice, which is to be as an quite critical but quite interesting to learn, that is to be having one of the 11th Bravais lattice is to be of a fifth crystal system. This is one another crystal system. The previous one example was to be related with the one crystal system. This one is again to be having the another crystal system is to be there. But if you look at carefully, a and b vectors are equal, and that's why if you look at this, a and the b is going to be the equal. But it is not equal to c is going to be there, but b is not equal to c. That means a is not also equal to c. A and b are equal, but this means to be a and b, but c is not going to be equal to this a and b. That's why this c is going to be the different from a and b. Again, alpha and beta are having the 90 degree. That means the angle between the b and c vector and the angle between the c and a vector is 90 degree. But as far as the angle in between the a and b vector, it is nothing but to be 120 degrees to be there, and that is to be gamma. It is shown with the 120 degree. So this is what the simple variation in between their structures are to be there, or lengths or the angles is to be there. As far as there are three unit cells are going to be used here. This one is the one unit cell, this one is the another unit cell, and this one is the another unit cell. So these are the three unit cells are combined here. Now this type of the structure is simply gives you the hexagonal structure, and all the points are exactly on the corners, and that's why it is called to be as an simple hexagonal, and or the primitive simple or the primitive. That's why the word p is going to be used here. As far as the examples for the such type of the Bravais lattices are to be there, Mg, Zn, Cd and Ni. Yes, that is magnesium, zinc, cadmium and nickel arsenide is to be the examples for the such type of the Bravais lattice is to be there, or the three-dimensional Bravais lattice is going to be there. The another one example of the your Bravais lattice which comes under the your sixth crystal lattice, and that is the 12th Bravais lattice is going to be there. And this 12th Bravais lattice is having what type of the variations. If you look at here, all these three vectors a b c are not equal to each other. That's why it is written a different, b and c vectors are of different lengths are to be there. And if you look at this case where it is to be as a very important factor, that alpha and the gamma is equal to 90 degree. Alpha and the gamma is 90 degree. That means what? As far as alpha is going to be there, it is the angle in between the vector b and c, and this is what it is 90 degree. And again, as far as the gamma is nothing but to be the angle between vector a and b, and that is what this is also to be of 90 degree. But alpha and gamma are 90 degree but not equal to this beta. The beta is not exactly equal to the 90 degree. This one is the beta angle, and the beta angle is in between the vector c and a is to be there. And that is what the difference as far as the such type of the crystal lattices or the 12th Bravais lattice is going to be concerned. And it is such type of the case where the all the atoms are exactly on the corners of the your cube, and that's why it is called to be as an simple monoclinic is to be there. And as far as the simple word comes, it is primitive also called to be as in. That's why the notification p is to be there. It is having the example of CaSO4 and 2H2O is to be there. And this is what the your 12th Bravais lattice is going to be concerned. Now moving forward for the 13th Bravais lattice, if you look at, it is little bit of same crystal lattice, that is sixth crystal system is going to be there. That means as the similar crystal system is to be there, a is not equal to b is not equal to c is to be there. Again, alpha and the gamma is 90 degree, but it is not equal to the beta. And this is what the case where the points are on the corner as well as at the top, center of the top and the bottom of the top is to be there. And that's why this one here is additional point and here is the additional point, and that is nothing but to be end centered monoclinic is to be there. And that's why it is to be noted with the p. And gypsum is the example for the such type of the Bravais lattices are to be concerned. So this is the one another sixth crystal system or the 13th Bravais lattice is to be there. Now moving forward for the last three-dimensional Bravais lattice, that is seventh contains with the seventh crystal system, and it is the comes under the triclinic factor. Now what exactly there, let's see. It is showing you that a is not equal to b is not equal to c. That means all three vectors are of a different length, or the sizes are to be there, and alpha is not equal to beta is not equal to gamma is not equal to 90. That means alpha, beta, gamma, all these angles are not equal to 90 degree. They are of different angles, and such type of the where all the points are exactly on the corners, not anywhere inside these surfaces of the cube. And that's why such type of the your three-dimensional Bravais lattice is called to be as an simple triclinic is to be there. As far as the word simple comes, the notation is to be, or the symbol is p for it, and the example for this is to be k2 Cr2O7 is to be there. This is what the 14th Bravais lattice or the 7th crystal system is going to be concerned. In brief, what exactly this part is going to be there? It is giving you totally as in three-dimensional Bravais lattices are to be there. That's what we have seen. The possible number of Bravais lattices. Bravais lattices are those contents or those follows the point groups, and in three-dimensional Bravais lattice there are 32 point groups are to be there, and using these 32 point groups, when any lattice is going to be created, such type of the lattice is nothing but to be called your Bravais lattice. And in three-dimensional case, the possible number of Bravais lattices are 14, and the crystal systems are, it is giving you the 7 crystal systems are to be there. This is all about the your three-dimensional Bravais lattices are to be there. From my side, these three-dimensional Bravais lattices are going to be completed. So yesterday we have seen two-dimensional, and today we have completed the three-dimensional Bravais lattices are to be there. That is the nothing but to be types of the lattices are to be there. So once again, thank you very much. Be safe and be at home for that. Thank you.